she started her own. Let me get this. Oh boy. Yeah, she started her own Life in the Soil consultancy after working with Elaine directly, called Doctere, and she is based in Quebec. Vivian is just extraordinary for her work on farms. She's the co-founder of the Valhalla movement. I was just super excited to bring her on because she can show if you learn from Elaine directly what you can achieve, and she's moving towards her dream of being a professional soil consultant, and she's doing it. She is an example of what you can do if you follow on this path. So I'm going to let her talk. Vivian, go ahead and talk about your experiences.
So yeah, that's it. I went through McGill School of Environment. I was very concerned with the state of the climate, world, the humanitarian issues, and obviously food and environmental crisis. Did a lot of ecological field work, studied in permaculture, but it wasn't till I came across Elaine's work that things finally clicked and everything finally made sense to me. It can be very depressing being an environmental scientist if you don't have if you're not armed with solutions that are concrete and attainable. And so that's what Soil Food Web theory and practice offers. And so I went through Elaine's courses, I guess, when was it now? 2 to 3 years ago. I guess it was one of the earlier groups, the beginning of Elaine's courses, and it just blew my mind. Every missing piece, because we studied soil science at McGill in the School of Environment, and just nothing really made any sense. And this biological approach to influencing the chemistry and the physics of the soil just is something that was never spoken about, but it just resonated a lot with me. And my experiences in the field and what I know from agroecological principles in permaculture. So I had met Elaine at a permaculture convergence, and she said, well, you should take my courses. And I was like, I can? There is such a thing? And yes, and that's what I did. So today I've been through that. I've been lucky to continually have Elaine's support, which is amazing, and everybody who goes through her courses and the certification will always have Elaine and Carol Ann, her assistants, support for them. I've since started my own company called Docteur, which is a play on words. It means soil doctor in French, because we do have a lot of work to do. There are a lot of major problems that are soil related, and it's starting to catch international attention. And what is there is, we have the solutions, we have the science, we have the theory, but what we're missing are landowners who are equipped to implement this on their lands, and more consultants to be there in the various regions around the world to help people transition. So that's kind of why I like joining in on the webinars, to offer my experience. I guess the next slide. So with my company, I've been able to, I have a lab where I receive soil samples from across Canada, compost samples from across Canada, and biological amendment products for testing. And I provide that service for the Canadians and the Quebecois. And I also provide expertise and consultants. I have a small-scale inoculum production that I provide. I provide assistance for farmers transitioning or who are trying to build their compost themselves, and obviously providing microbial treatments. I don't know if the next slide is up, but is it up? Can somebody confirm to me? Here we go. So this is just one example. Again, there was a lot of grass. If I had known which examples, maybe I would have chosen a different one from Valhalla, but this is two houses. On the left is obviously the house whose lawn I treated, and on the right wasn't treated. At the beginning of the season, the lawn, I actually have a before picture that goes along with this. I probably should have put in here, where both sides of the lawn look exactly the same, just as lifeless and spotty and full of weeds. And what I did on the left side is I overseeded with a stronger grass, and I applied compost teas 3 times. And what's interesting about this case study is the people who owned the left side of the lawn, the house, got ill. The husband got ill, and they were not home the whole summer, which means that this was never irrigated. And last summer, this was in Ottawa, southern, the end of August. And this is a picture at the beginning of August of this lawn. So it just goes to show, you know, water retention capabilities from those moments where it did rain a little bit. The long grass catching the morning dew, the fungi building the structure, their predators releasing them. This is a good example of that. And I was able to learn all of this in Elaine's courses. Next slide, please. Just waiting for the next slide.
So sometimes there's a gap because you're in Quebec and I'm in California, but let me know when you can see that.
Okay. Sorry, everybody. Can
you see it all right?
No, I can't, but I guess if everybody else can see it, I'll go into the exclusive offer for you guys, the webinar attendees. So there's a limited time offer on all of discount on all of Elaine's courses. So Life in the Soil, Compost, Compost Tea, and Microscope. It's a really great opportunity. The investment is totally worth it. I paid for this, and I thought it was expensive at the time, and the minute I started the class, that word expensive went out the window, because the amount of information, the value, after having gone through McGill and working at the Smithsonian Tropical Research Institute, and here I am on this in these courses with Elaine, and it was just the most pertinent information that I've been waiting to hear my whole life. So let's skip into the next slide. The Life in the Soils class, this is the first class that you should take because it explains all of the theory that goes behind, you know, who are the microbes, what are their ecological functions, what does it mean when they're not there, what is mineralization, what's the nutrient cycle, how do the microbes actually compete against diseases and suppress pests, the actual logic, the science behind the how. Why is it that the fungi build the structure? Why is it that when they're there, they're able to release, suck minerals out of the rocks and into their bodies, which their predators will release to their plants? Why is it that they hold nutrients? Why is it that when we till, we destroy all this stuff? Why don't we till in our organic matter? Why should we stop tilling in our cover crops every year? All of this kind of information, the theory behind soil food web science, is in this course with a lot more case studies as well. So this is on an exclusive deal. You're saving $1,000 from an original price of $1,997 American to $997 American. So that's a great deal. And everyone, I'm also a mentor with Elaine, and so the students who, after they go through the classes and they want to become consultants, they do the certification to become certified soil life consultants. Now, if you're just working on your farm, you don't need to do this, but if you wanted to become a consultant, this is the process. And everyone I've spoken to this course has just opened their eyes in so many ways and changed a lot about the way that they work. There are even farmers that are going through this process, and some who were close to just shutting down before they started these courses. So highly recommend. Next slide, please. And then there is the compost class. Compost is very much an art and a science, as you'll discover. There's a lot of it depends, and actually there's a lot of it depends in general in soil food web science. It depends how bad was your soil in the first place. It depends how good was your compost to begin with. So how do you make fungal compost? Well, it depends. What ingredients do you have to put in, and then what ratios are you putting them in? So how do you make bacterial compost? How do you make fungal compost? How do you make compost that you can guarantee you've killed off all the diseases, pests, the weed seeds? How do you make the compost that contains all of the soil food web that Elaine has been talking about? These are the stars of the show, and nothing happens if you don't have compost. So the compost course is very essential. Ooh, ooh, thank you. And there's the compost tea course, which, as Elaine mentioned, goes over compost teas and extract production. Compost teas and extracts are not the same. They're not used in the same scenarios either. So if you don't understand that, this would be a very good course for you. Compost tea extract course also obviously goes through the science of producing teas that are catered to the microbial needs of your situation. All right, I have compost that has about equal parts fungi to bacteria, but I need to treat the soil around my fruit tree that needs about 5 to 10 times more fungal dominance. So how, with this compost, do I make a compost tea that is way more fungally dominated than the original compost? How do I multiply my amoebas, my nematodes, etc.? You can also use this to, heal soils, to inoculate bad compost piles or other people's compost piles. So this is another skill that it's not willy-nilly. So it's a very good course to take. And then the third one is the microscopy course. This obviously is essential, because if you want to be sure that you are producing the right biology, that you have the total food web, and you want to be doing this on your own, you don't want to be sending it off to a lab all the time, or even if you just want to kind of have an idea of how good you're going, you need the microscope course. In this course, Elaine teaches you all about how to identify these different organisms and how to count them in such a way that at the end you have biomass counts and ratios for all of the organisms. And then further than that, what does that mean? What does this data tell you about the health of your soil or the quality of your compost? So these are all really important classes, and like I said, I've dealt with a lot of other students that I am very much in communication with who start on the microscope class, and they immediately freak out. Oh my God, this is like overwhelming, da, 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 da. And let me just say, like, if you've never farmed before and you buy a farmland and a pair of rain boots, you won't wake up the next day a professional farmer. So by taking this microscope course and just buying the microscope will not make you a professional person on the microscope. You need to listen to the courses several times, you need to attend the webinars, and you need to practice and talk with your peers. We do give you a chance to connect on Facebook with other people who are in these courses so that you can ask questions, take pictures of something you don't know, and identify them. Each one of these courses individually is $500 American. Or you could buy them in a package for $2,494 American, which was previously $5,000. This is definitely worth the investment. It's becoming the hottest topic, and everybody I know who's gone through this process has not had one single regret. The great thing about these courses, too, is that if you have questions, there are live webinars with Elaine every few weeks or so, and you pre-submit your questions, and she'll answer as many as she can, and use your student group support. And you also are guaranteed your money back if you are not satisfied. So you can buy this without risk. You do not need to become a certified soil life consultant to do these 4 courses. You could just do these 4 courses and decide to integrate it on your land or in your own projects. If you do want to become a consultant, there is a further step called the certification process, and that you can find out more about at lifeinthesoilcourses.com. Classes, not courses.com. So that's my bit, and I hope you enjoyed Elaine's amazing presentation. Every time I hear from her, I just learn so much, and I hope you did too. Thanks.
All right, awesome. Thanks, Vivian. All right, fantastic. Okay, now we got an exciting thing.
Time for the raffle.
It's time for the raffle. What are you gonna win? Access to the Life in the Soils class. This was tough because I put the word out for anyone who signs up is automatically entered, and I just said, hey, leave me a message, and I got 2,000 messages, and most were just absolutely incredible. You know, like I am a Hopi elder attending from my tribe, or like I'm managing 2,000 acres, like I had a message, you know, like taking care of a whole tribe of people in Thailand. It was, you guys were killing me. It's so tough to narrow it down to 100 people, let alone 10 people. But now I'm down to 10 names in a hat. So here we go. Out of the 10 names in the hat, who's gonna get a chance to win the Life in the Soils class? Oh, by the way, Neil and I are both taking the class, and it is phenomenal. It's every single lesson is like more than I learned in the whole year of college at biology class. Okay, here we go. It's killing me. This is tough. All right, here we go. The winner is Lizzie Rice-Troffer, but she has to be here. The winner has to be here as one of the attendees, and if she's not, we have to move on to someone else.
Wait, is Lizzie here?
Well, we'll see. That's the thing. If she has to be here, because we got 10 other people.
What if none of them are here?
Oh boy, yeah. Then nobody wins. No.
If none of the 10 are here, then I think it goes back to Lizzie.
Okay, Lizzie's a no. We got Ryan Lunello. Let's see if you're here, Ryan. Oh man, I just should have stuck around to the end. I'm sorry, Ryan. Okay, here we go. Jorge Lemus. I know you were here earlier. He's a farmer from Mexico. He's got some acreages. Jorge, let's see. Are you here at the moment? Come on, Jorge.
There he is.
Jorge. Okay, Jorge. Congratulations. There you are.
You win a free Life in the Soils class.
Life in the Soils class. Hopefully that's going to help you and your farm and your family down in Mexico. So, yeah, type in the chat box below.
Jorge's the winner.
Congratulations, Jorge. I know you're going to learn a ton. It's absolutely phenomenal. So, without further ado, how about we get started with some questions? Okay, Elaine, you want to turn your webcam back on?
Okay, there we go.
How about I turn the Q&A thing off? And just in case anybody's wondering, we're going to send this replay out to all the attendees. You'll get the offer, the links talked about, and the PDF. And there's a little handout tab down below in the control panel where you can download all the things that we talked about, the PDF of the presentation, the offer, and the contact info about Life in the Soils, the consultants, Neil and I, in case you want to get a hold of us. So, Q&A time.
We're also sending out the link to our free, you each get a free week of membership at Sustainable Design Masterclass, which means you can access all of our previous webinars for free for a week. There's about 40 of them with some folks doing really cool work all over the planet.
Yeah,
so,
and the way to get that is in the replay email, you'll just need to send me an email like, hey, I want to give me 1 week free. I'll give you a little prompt in the email, and then I'll send the promo to you.
Okay, let's do some questions.
Awesome.
One of the things I'm noticing in the questions is a lot of people are asking, is there a certified consultant in Nicaragua or one in Europe someplace or one in Sweden? And for that, you really need to go to our website, the Environment Celebration website, to look at the list of certified consultants. We have a lot of people in training as well, and so you might want to email Environment Celebration directly and ask for your specific location if there's someone who's the closest person to you that could be helping. Vivian, for example, has quite a few students. I think we've overwhelmed her with the number of students in Canada, so I think that's kind of full up for the time being, but we have new people coming on board. So for example, in Sweden, we do have a person that is just about finished with their certification. So we'd certainly connect you up to Joseph and get the two of you working together. I'll probably be your fallback advisor, whereas Joseph would be there close enough at the day-to-day questions that you might have, you would be able to talk with him. So go ahead and email us. Let us try to hook you up with the closest person that we've got. So how do you want to do the questions?
Okay, how about I can help you group them, because there's going to be, and for all the folks that are waiting to get your questions asked, now's the time. So type them down below, and then we're going to get to them. But just be aware, we got about almost 500 people on for our Q&A session.
We'll get to as many as we can.
We'll get to as many as we can.
Well, while you're looking through them to get an idea, that somebody asked where the classes were held. All the classes are online. So all of them, you sign up for the class you want or for the whole group, and we give you a password. And that's your personal password. It's unique. Nobody else gets it. And then you have access to that course for a full year. Because what I always discover is somebody goes through the classes, you buzz through them as rapidly because you want to hear all this good stuff. You want to learn all these techniques and methods. And then you need to come back and re-listen to sections time and time and time again. I always have to giggle when somebody comes up to me and says, I've listened to you for 54 times, and Dr. Ingham, you sound exactly like you sound you sound in real life, exactly like you sound on the videos. It's like, good thing. But go back and re-listen to things. Don't just breeze through it once. There's so much information in there, and you want to perhaps go back and re-listen to different sections. So, Raleigh, any questions for me?
Okay, so here's one that I heard earlier. It was from Yurik. He asked, would you encourage people to compost human manure?
It's certainly possible. You really have to question who is your clients, who is going to actually be using your compost, because there's a lot of people who are like, oh no, I could never touch, human waste material, human manure. That's just too creepy. When you take that organic matter from human feces and put it in a compost pile, the microorganisms are going to chew it up. They're going to completely decompose it and turn it into microbial biomass. And what's creepy about microbial biomass, about bacteria and fungi and protozoa and nematodes? Well, wait a minute. There's some people who have problems with that. So pay attention to your audience, and if your audience understands that we are doing a conversion process, that there isn't going to be any human feces left in, human manure left in that compost pile after a very short period of time, they have no problems utilizing that compost. But you can get homeowners and us backyard gardeners who just, oh, it's icky. They don't want to touch it. So be aware. Certainly if you're making that compost for yourself, it's that human manure is completely gone by the time you're finished composting.
Okay, so another question was, here's a question from John about aquaponics. He's asking, has any research been done with dual root zone media bed aquaponics in the soil food web? Good question.
Yeah, I don't know what the dual root system aquaponics is, so I would certainly ask him to send that question to me with maybe a link to what a dual root system aquaponics actually is. It sounds like maybe half of the root system is in soil and half of the root system is in the the trough with the water flowing by. Yeah, I'm going to have to beg off on that question because he needs to let me know about that specific type of aquaponics. But we have done quite a fair amount of work with hydroponics, aquaponics, fish in the system, no fish in the system. Yeah, so, yes, I've done a lot of work on that. I'm just not quite sure about your specific type of aquaponics, sorry.
All right, fair enough. So Tom Cantino asks, how much variety is there in the types of compost and compost teas?
It's almost to the point where probably every compost, compost tea, compost extract is unique in some way, because you're never going to have exactly the same sets of organic materials going in. You're not going to ever have exactly the same number of species. So how specific do you want to get in your definition of sameness? When we get around to looking at bacteria, fungi, protozoa, and nematodes, there's a lot of similarity between looking at those characteristics, the amount of humic acid, fulvic acid, oleic acids, the smaller chain carbohydrates, proteins, amino acids. There's always some variation because it depends on exactly which species, what are the conditions, how aerobic is it, exactly what are their waste products coming out. But if you look at it from a more general approach, are you looking at fungal food or bacterial food? Most composts are remarkably similar depending on your starting materials. Did you put more fungal foods in, then you're going to end up with more fungi and probably still have a lot of fungal foods.
Cool. So here's a question from Wendy. Wendy, you're actually one of the people in the hat. Sorry, I didn't get to pick you. But she says, hi, I live on a mountainside in a warm, temperate to Mediterranean climate. Soils are generally thin, less than half a meter. I've been making lots of compost and compost teas, use woody mulch. I've seen lots of improvements in the area, but we're in a drought situation. No rain since March, currently in record temperatures through the summer and the soil everywhere, treated and untreated, as dry as bone. Will I need to start again, or can soil biology survive drought?
Soil biology will survive drought. What they'll do is all go dormant. So in the case of bacteria, they have specific dormant stages, quite often spores, or they'll have resting stages where they really need to get inside an aggregate. It's kind of like you and me. When the temperature gets really hot and no wind, it's just really uncomfortable, we go to that micro aggregate called the hammock and sit down inside of it and just kind of, make it through that unpleasant, hot, dry situation that can happen in the middle of the summertime. So their hammock is that micro aggregate in the soil. They're in the middle of that micro aggregate just hanging out with all of their buddies. And when moisture comes, then they'll start growing rapidly. They'll start doing their processes once again. So typically in that dry summer, end of summer period, your plant's really not doing much of anything other than ripening the fruit, finishing off the seed production, going senescent. And so your plant is then going to pull all of the nutrients from the above ground part of the plant down into the root system, storing things away. Not a lot of activity is needed in the soil. The plant's not putting out a lot of exudates. So the microorganisms are all in that just really relaxed, mellow condition, taking it easy, going dormant, making spores and cysts and eggs, and waiting for those fall rains to arrive. They definitely can survive that drought period. Give them enough advance notice. The problems for microorganisms come when you abruptly change their environment. You've been growing them at 80 degrees, and all of a sudden you drop them off in a place that's 35 degrees. They're just going to go into shock, and many of them die. Microorganisms that are used to living at close to freezing temperatures, and all of a sudden you put them in a tropical system. Most of them are not going to survive because they just don't have the time to go into those dormant stages before they're dried out or frozen or just too hot for them to deal with things. Okay?
Awesome. Okay, so question from Elaine. He asks, how do I control the fungal concentration in a compost pile? How can I control bacterial and fungal concentrations in general?
By the foods that you put in. So when we're making a compost pile, for example, we're going to typically put in 10% high nitrogen containing materials, legumes, manures, things like that. Grains, the seed itself is usually pretty high, and that's going to grow a lot of bacteria, but some fungi as well. And then we're going to want to put in bacterial foods. How bacterial do you want your pile? So you're going to put in somewhere between 10% green plant material, bacterial foods, up to as much as perhaps 40% green bacterial foods. And so you're going to be promoting those bacteria that utilize those plant materials, enhancing and growing their population. And then we're typically, for fungi, going to be putting somewhere between 10% and 60% of the pile, depending on what microorganisms in your soil you have to bring back. And you always want to go back to that soil. I have no fungi. So it doesn't matter what kind of plant you're going to grow. You're going to make a fungal dominated pile, because what you have to fix is the complete and total lack of fungi in your soil. But let's say you look at your soil and you're already at 300 micrograms. You're already at 50% of the microbial population is fungi. Well, what crop are you trying to grow? If you're growing a plant that needs 70% of the population to be bacterial, then you're going to want to make a bacterial pile. But let's say you're now instead trying to grow something that requires 70% fungal. Well, then you're still going to make a fungal dominated pile, because you still need that fungal improvement. So what are fungal foods? What are bacterial foods? You've got to look at the complexity of that organic matter, and there's a number of tables in the composting seminar, that the compost class, that we go through what kinds of foods are fungal, what kinds of foods are more bacterial.
All right, excellent. So Lisa had a question. I think it's probably a pretty quick question. Please talk about the ways to remove chloramines from municipal water used in urban agriculture situations.
You typically want to use a fairly complex organic acid. And the easiest one for you to be able to make your own is to make a compost pile. Make sure that you get that nice, rich, dark brown color to the compost. And then when you passively run water through your compost, you're going to extract the humic acid. And so the water comes out, it has that nice, rich 70% cocoa chocolate color. And then you know you've got a good concentration of humic acid. Add that humic acid at 1 drop per gallon of your city water that's got chlorine and or chloramine in it. You've got to complex those things because chlorine and chloramine are meant to kill microorganisms in your drinking water. You don't want them in your drinking water, but we don't want the things that suppress microbial growth in that water that you're going to use to water your lawn or water your garden or water your compost piles. So 1 drop of humic acid per gallon of your city water should neutralize that humic acid. Sorry, should neutralize the chlorine and the chloramine. I'm getting distracted by other things here. So the humic acid complexes. Now the humic acid won't complex chlorine and chloramine forever. If you want to hold on to that water that you've complexed the humic acid with chlorine and the chloramine, if you want to keep it for a long time, you've got to get some microorganisms in there to actually take apart the chloramine, and the chlorine molecule has to get stuck into the structure of the organic matter. So simply adding the humic acid is good for a couple weeks of tying it up, but after that you really need to have microbial growth on it. I probably wasn't part of the question that you asked, but sorry, you got that information anyway. Okay?
Okay. Question from Julie. She's actually a Life in the Soil class participant. She says, I'd like to know all the possible costs for compost not reaching or sustaining 131 degrees Fahrenheit, 54 Celsius. I'm working my way through the courses, have made 3 compost heaps now. Only the first one shot straight up to temp, maintained it for several days, but it returned the temperature after turning.
You didn't put in enough high nitrogen. Whatever you thought was high nitrogen, whatever you actually used, figuring that you were going to get to that 10% high nitrogen, one of those components wasn't actually high nitrogen. And quite often we have this problem with manure. If the manure is sat around outside, gone anaerobic, most of the nitrogen will have volatilized, have left as a gas, as ammonia, and so it's not high nitrogen anymore. If the animals are being put out on pastures that do not have good grass, they don't have really good food for the animals, their manure will not be high in nitrogen. They're barely pulling the nutrients that they need out of that grass and barely making it. So we'll be looking at that manure and making sure that it is quality material. Look at the pasture. What are the animals being fed? If animals are being given grains of any kind, then usually that's going to be really high in nitrogen. When you think about human manure, if you got human manure from vegans or vegetarians, there's not going to be a whole lot of nitrogen in that manure. So you might have to double or triple the amount of that sort of manure that you were putting into your compost pile to generate heat. Whereas if you were getting manure from somebody who eats steak and potatoes every meal that they possibly can, because meat is so high in nitrogen, so much of that nitrogen comes out in their manure, that's going to be a real hot source. Take a look at the legumes. That's the other choice of another choice of high nitrogen containing material. You've got to look at the root systems of those legumes for the nodules present on that root system. If there are no nodules on the root system of your alfalfa or your lucerne or your beans or peas, then that plant material is not going to be high nitrogen. The beans and the peas are not going to be good food for you and your family because it's lacking the proteins and the amino acids that you need. That's why you eat those kinds of materials. So be looking on the root systems for those nodules. If there are nodules, so you're looking at those little round, marble size, we would really like them to be marble size, you want to cut them open. And a nodule that's actually fixing nitrogen will be a bright red like blood on the inside of the nodule. If you open up a nodule and it's green or it's black or it's purple or white, it's not fixing nitrogen. So again, it can't be used as a high nitrogen component in your compost. Another factor to think about is when you are wetting up your compost, are you using water that's from a really cold source? So often when you're pulling water from a well, the temperature is down around 40 degrees. And so you're mixing a really cold material into your pile, and that really shuts things down for a while. You know, maybe they'll get going, and then you turn the pile to reduce the temperature because it's been high enough long enough, but you use cold water to water the pile, may just shut all of those organisms down. Again, it was what I was talking about in the previous question, where you take your organisms from 150 degrees and you now use 40-degree water. How would you feel? That sudden shock, so many of the organisms die. So be a little careful about that. So those are very common problems, but there's probably 2 or 3 more things I could come up with, and that should be covered in the compost course as well, talking about how do you maintain that temperature. Yeah, that's probably enough of an answer on that for on and on and on. Okay.
Elaine, what's your take? We've got 2 questions about anaerobic uses, one from bokashi composting and one from a biogas digester. Like, I know the biogas digesters use an anaerobic thing to produce the biogas, but what's your take on using the residues from biogas digesters and on bokashi composting systems?
Yeah, both of those are anaerobic systems, and you're in that process. Oxygen has been dropped purposely, and the rapid growth of the bacteria, typically in both of those situations, is enough to drop that oxygen concentration down to quite low levels. In bokashi, it usually drops around 4 to 5 parts per million. In an anaerobic digester, you may well be down around 2 parts per million, especially if you're trying to produce methane or hydrogen gas. You have to reach those really low oxygen levels. So the bacteria that are growing in those systems are not typically highly beneficial to the plant. The problems are that they either produce alcohol of some kind, or they're producing gas that will kill your root system, like methane or hydrogen, or very toxic volatile chemical. In the case of bokashi, quite often it's lactic acid that's being produced. And lactic acid has a pH of around 2 when you're dealing with pure lactic acid. The pH is quite low, and that by itself will solubilize your root system, basically turn it into slime. And it's hard for slime to take nutrients up from the soil and give them to the rest of the plant. So those are the kinds of problems that we're dealing with anaerobic conditions. A lot of people will use those anaerobic products, the acids, the low pH acids, the alcohols, the volatile compounds that are highly toxic, and they'll apply them to plants that are being attacked by pests or insects, fungal diseases. And they are pretty good pesticides, but they're pesticides. They're going to not kill just the pest. They're going to kill all kinds of other beneficial organisms at the same time. And so if you choose to use those things in those ways, you're going to have to replenish the beneficial aerobic organisms that need to be there. So if you've got bokashi residues, mix them up, get the oxygen back in there. Mix that with your greens, your high nitrogens, your woody materials, and I would suggest to you that the residue from a bokashi pile or the residue that comes out of an anaerobic digester should be considered woody materials. But you're going to have to get oxygen into them and try to shut down the growth of those anaerobic organisms, because those are not what we want to grow in a compost that we're going to put plants into.
Okay. So a question from Katie. Got a few questions about just remediation, about metals, insecticides, fungicides, herbicides, etc. She asked what to do after being crop dusted with an insecticide by a local vector control, how to prevent it from happening again, and how to remediate your soil.
Yeah, what you would want to do as rapidly as possible would be to get back out into your your field and apply a compost tea to everything, because the insecticide has killed a whole slew of highly beneficial organisms, and you need to get them back as rapidly as possible, because you don't want to have to go out there and use some more pesticides and insecticides, yada yada, to keep those populations down. So get out there as soon as you possibly can with a good compost tea. How do you prevent that from happening again? Talk to your local authorities. In most places, there are laws against drift coming into your property and causing problems. So you might need to document what was on your leaf surfaces, and then after the insecticide, how much was lost. And so, send those plant leaf materials into an SFI lab that's near you. Or we've got a laboratory that takes samples from overseas in Corvallis, Oregon, so you could send it to that lab. And then you've got the proof of the damage that was done by that insecticide, and the fact that you now had to spend how much money in applying the proper biology to protect your plants. What was the third part of that question, Raleigh?
I believe one was on heavy metals, like how to remove heavy metals from the soil.
Yep. With the heavy metals, you need to add in those microorganisms that are known to take that heavy metal and put it into the structure of the organic matter. So there's quite a few fungi that are very well known to be able to do those kinds of things. So like King Stropharia, there's a number of hyphalomas. There are a number of bacteria that will do that as well, but they are all very specific to the kind of heavy metal that you're dealing with, or the kind of insecticide or pesticide that you're dealing with, who is going to decompose those materials. So like with the example of the insecticide being sprayed, what does she do with getting rid of the insecticide? With that application of the compost tea immediately after, those microorganisms, some of them, a whole slew of them probably, are perfectly capable of dealing with that insecticide to break it down and decompose it. And generally what we require is a number of organisms that will produce the specific enzyme to break the benzene ring, to pull the chlorines or the bromines or the toxic chemicals off of the surface of that benzene ring, break it down, stick all of those compounds into the structure of the organic matter that they're growing on, and that gets rid of the problem basically. Half-life, shelf life on the carbon chains that they've stuck those heavy metals into, or the chlorines, the bromines, etc., things like that, is usually about 500 years before half of that material is going to be released. So it's a very slow release and not going to harm any of your organisms in the soil. So those bacteria and fungi dealing with the insecticides, the pesticides, the herbicides, most of those we're going to be applying in a compost tea, in a compost application, a compost extract application. It's the heavy metals where you have to have the specific or microorganisms that can take that heavy metal and stick it into the structure of the organic matter. So there I would probably suggest that you try to get hold of Paul Stamets' company. He does a lot of work with those heavy metals. There's a couple more companies where they know which microorganisms are specific for which pesticides or heavy metals in various conditions. So there's also a factor: are you in a very wet climate? Are you in a very dry climate? Are you in a Mediterranean climate? And things have, different microorganisms have to be used in those different areas. So that's, get a hold of an expert that can help you with those.
I'm going to chime in on the end of that because we did a webinar with Peter McCoy that any of you with questions about this can access since you have a free week. But Peter is the author of Radical Mycology. If you want to try to approach that on your own without hiring somebody, I recommend you get started with his book.
Yes. Thanks for
Peter McCoy's Radical Mycology.
Yeah, really, it's mind-blowing work with the fungi is one of the most important things I've ever learned about, and I think what people need to start learning about more. So a lot of questions about how to find, this question is, where can I get a list of fungi to bacteria ratios for crops? And other people are asking, how do you find the right fungi to bacteria ratios for plants?
I go over that in the Life in the Soil course, so that first course that Vivian was talking about, where we go through the whole theory, the research and the science that we've done establishing those fungal to bacterial ratios. Generally, plants that come very early in succession, the weeds and things like that, they have to be bacterial dominated. If you want to grow weeds, make your soil very bacterial dominated. Well, okay, that's exactly what we do in conventional agriculture is we till too much, we put on all kinds of toxic chemicals, we're putting out those inorganic fertilizers, and the only thing that survives that is a whole boatload of not so wonderful bacteria. So perfect condition for weeds to grow. We want to move beyond that. And so think of succession. Where does your plant fall in that successional process? And I go through that whole explanation of, step by step going through the whole successional sequence, and that really gives you a framework that you can answer that question for any crop that you're interested in.
All right, awesome. So here's a question from our winner, Jorge. He's asking, he's using compost tea in large scale, on a large scale with tractor sprayers. He's saying, what will the maximum pressure be that the fungi and bacteria can stand?
When the organisms are in the water and you're blowing them out, they are very resilient. What we're seeing is, well above 600 psi is not a problem. Quite often we're trying to get microorganisms to the top of Douglas fir trees or ponderosa or something that's 200-300 feet tall. And so we have to use 6,000 psi to blow the organisms up there, and that doesn't bother them at all. Being blown out of the cannon doesn't bother them. It's what speed are they going? What is the pressure that they land on that leaf surface? So if you're at 5 psi, but you're spraying on a leaf that's only this far away, that smack into the concrete wall is going to kill the organisms, even at 5 psi. It's kind of like when you're driving your car, even though you're only going 35 miles an hour, you hit something, you destroy your car because the smack is what is the problem. So how do you know if you are applying that biology at too high a pressure? Typically, you're starting to cause damage to the leaves on your plant. So if the pressure is too high and you're going to be killing your organisms, you're going to be killing your leaves. You're ripping the leaves apart. Typically, we want to be around 80 to no more than 100 psi when we're applying that to the leaf, so whatever that pressure is. So we're not causing any damage to the leaf. There's no ripping, there's no tearing, there's no leaves flying off the plant. Everything should be fine. When we're applying at 6,000 psi to get to the top of that really tall tree, by the time that material is at the top of the tree and it lands on the tree, it's at 0 psi. So it's the pressure that it hits the plant material. That's what the problem is. You've got to be looking at what that pressure is. Okay?
All right, excellent. Well, boy, this is tough. There's 400 of you sticking around to get your questions asked. A lot of them are very specific and some are very general. Here's one from Osmia. She's asking, has your organization done work with foresters or loggers to repair the soil after clear cutting?
we've done a fair amount of that. Usually the restriction when we get to dealing with forests is that they are just such massive acreages. And you know, getting that much compost, getting that much extract, getting that much tea, oh, it's a little bit mind-boggling, but I'm sure we'll get there someday. We currently are working on a clear-cut area, and we're going to go in with after they've gotten rid of all of the slash and they've pulled all of that off, if it's possible to get them to chip up the slash and be able to spread those wood chips back out on the property. That is a very good thing. We need something to help stabilize that soil after a clear cut or a fire. If we can be chipping things up to put that carbon back into the system, then we'll come along with a compost tea spray. And quite often we'll be doing that from helicopter, just because it's such vast acreage. So usually that you're dealing with a forest. So we're spraying that compost tea from the helicopter, and certainly the blades of the helicopter help disperse that tea and spread it very evenly over all of that surface. And that is going to get that soil restructured, so when it starts to rain, you're not going to have all of that erosion and loss of the soil from that surface. The plants typically come the spring, or looking at a spring seeded plant or fall seeded plant, we soak the or cover the seed that we're going to spread out, and again often by helicopter or by airplane that the seed's going out, so that everything falling onto the surface of the soil gets in under the cracks and crevices of the wood chips, hopefully. First time it rains, that gets held in place and not just washed down the hill. So the seed itself is coming with the biology that that plant requires. So as soon as that seed germinates and grows, it's fully protected. Nutrient cycling starts up right away. We've got the mycorrhizal spores right there on the seed coat. So things germinate and successfully establish very rapidly. That's that's probably about as far as we've gone, because otherwise, trying to go out and improve growth of the plants by applying compost, that boggles my mind to have that much compost. Okay.
Okay, awesome. So, question from Keith Johnson. He's a pretty amazing permaculture designer. He's saying, Weir Farm has a well-established diverse cover crop. The orchard, sorry, it's worded strange. Okay, we have diverse cover crops including legumes, grasses, brassicas, along with previous applications of compost. How often will we need to apply teas and additional compost? The cover crops are not tilled, turning, but rather crimped and interplanted by drilling. This is on land mostly for grazing.
Yep. I would be monitoring with a microscope, because that's always the easiest way to answer that question. Do I need to put more compost out? What should my compost have in it to fix the problem? Does my compost have the microorganisms I need to fix the problem in my soil? Do I need to apply more? Have I fixed the problem? And all of those things are answered by using that microscope. We're not using really fancy schmancy microscopes. It's a simple shadowing technique that we use to help you see the bacteria and the ghost-like fungal hyphae and protozoa in the soil solution, and takes you 20 minutes max to get that slide prepared, look at it using the microscope and deciding what's missing. What do I have to fix? Is my compost good enough to fix that, or do I need to go make some more compost that's got a slightly different set of starting materials put into it? So the easiest answer to all of that is use a microscope and know for sure. Let's not guess. Let's not put out something where we think that this needs to be way more fungal than it is, so you put out a real fungal-dominated compost, and then you discover that you went too far. And now you got problems. So you should have put out a bacterial-dominated compost and you didn't because you didn't actually check and make sure. It's, you know, how can you manage if you can't measure what's going on?
All right, great. So, question from Pang. She said she asked this. Oh, never mind. A lot of questions about using animals in your compost. I'm
Yeah.
gonna try to find.
I would
Go ahead.
definitely indicate if you were going to put a whole carcass into your compost pile, you want to do a static pile. And that's a bit different from a thermal pile. In a thermal pile, we're trying to put together a mix that we're going to get that temperature up, we're going to kill the pathogens and the pests, and within 21 days, that pile is starting to cool again, and it hits ambient, you know, within 25, 27 days. So it's the fast composting approach. You make really good sets of microorganisms. But now, when you have lots of high nitrogen containing material that is going to go anaerobic if you don't put it in the right place, and you know, and deal with it, like if you were going to take a dead animal and chop it up and put that into your thermal compost pile, you would be having, I've got a fly here, you would be having a lot of trouble with hot spots and cold spots and trying to really compost everything properly if you put parts of a dead animal into a thermal pile. Just way too crazy, way too many pathogens could grow. So instead, you layer a lot of woody material at the bottom and then a mix of green and woody material together, and you lay the dead animal bodies on top of that pedestal. And then you cover them with, you know, if you've got 3 feet of dead animal bodies laying on the surface of your pedestal, you're going to go 9 feet tall with the green woody materials above that. The dead animal bodies are going to go anaerobic, and in this kind of composting process, you want them to go anaerobic because it's the strong acids that are produced under anaerobic conditions that chew up the bones, they chew up the hair, they chew up and decompose the hooves, the claws, the beaks, whatever, all of that hard chitinous kind of material will be decomposed in a very short period of time. Then you want to, you know, all of the anaerobic gases that are coming off have to be retained in that aerobic layer on the outside of that static pile. And in about, you know, 3 to 6 months, it's finished. You can open up the pile as long as you don't smell any bad smells while you're taking it down. You're good to go. The thicker the layer of dead animals, high nitrogen containing materials that you put in that pile, the longer you're going to have to let it compost. So it depends. In that particular one, what's your volume of high nitrogen? Dead animal materials that you put into the pile, that's going to determine how long it's going to take for it to fully decompose. Okay.
So I'm going to jump in for a sec because I did once compost an entire camel, and I'm happy to hear that we did it the right way.
Yes.
Good. It was more as a teaching tool than as something we actually were going to use on our plants, because this carcass had been sitting on the side of the road for 2 years and had not decomposed. And so I
cried out.
Yep. So I wanted to show that through compost we could actually get it to do that. And then all we found at the end was a hip bone and a jaw bone. So there you go. You can compost carcasses without problems.
Yeah, you can compost steel-belted radials. Just stick them in the middle along with all that dead. And so the rubber, and you know, people always say, "Oh, rubber, it's, you know, it's petroleum, it's terrible stuff," but it all came from plant material. You just have to have the right sets of microorganisms to decompose that material. And those microorganisms require very anaerobic conditions. They really like those organic acids that are produced under those very anaerobic conditions. And so they're more than happy to decompose the rubber or the petroleum products, plastic, not a problem. That's all organic material, but you have to provide the right conditions for that decomposition to occur.
Great. Awesome. Let's see. Two more questions. I got to take a 2-minute stop just for the show off Sustainable Design Masterclass and to show you guys the offer one more time again. But so Osmia asks, the title of this presentation refers to bringing ecosystems back to health. Because you can give us examples of these techniques being used to restore wild spaces to health, or restoring a lot of biodiversity.
I'm not aware of these kinds of techniques being used in, like, well, no, wait a minute, I do. So in Yellowstone National Park, after the last big fire that went through, gosh, it's got to be like 35, 40 years ago. After the fire, we wanted to see how rapidly places where the soil had burned so hot for so long because it had just a massive fuel load on that soil down into that soil. The organic matter layer was very, very, the organic matter at the surface of the soil was quite deep. It burned extremely hot in some of those areas, and the whole surface of the soil turned into glass. The heat involved was so hot it melted the silica in the soil. And then there were other spots that didn't take us backwards in succession quite so far. So weed fields came up the next year. Other places where there was still organic matter left on the soil surface, the grasses grew, so there was more food for the deer, the buffalo, the elk, and all of those herds increased in size. There were places where the fire wasn't quite so intense. It burned the trees, but it wasn't as intense, and shrubs came up the next year. Places where the fire was not so intense that the trees themselves were not burned. So we wanted to look at all of the consequences. What happened with the biology, and then did that biology start to move things along through that process of succession? So, the next year where the trees had burned, just the ash had gone down onto the surface of the soil, the understory had burned. It was just like putting in inorganic fertilizer. Lots of the trees grew a lot better for a short period of time, so the growth rings were a little bit wider. So fertilizer input, yes, even nature does it sometimes, but fire can't go through year after year after year, because then you end up destroying the system. So once every 150 years, once every 200 years, fire is probably going to allow a little bit more rapid growth. Where we were looking at the shrubs coming in, the fungal component had been definitely not knocked back, and so that fungal to bacterial biomass ratio was dependent on exactly where you were in the park, but 2 times more fungi as compared to 5 times more fungi, and shrubs grew up. Where we were 1-to-1 ratio fungi to bacteria, that's where the grasses, beautiful meadows, a lot more animals could grow. Annoying little fly. And so just exactly what we thought. We had already documented just by going to places that were in those stages, looking at the biology. Yep, we just kind of re-verified things that were already published. So then the places where the soil had burned so hot it had turned to glass, it took a very long time for some of those places to be broken up. The deer, the elk, the buffalo learn to avoid them, because when they step on that glass material, it will cut their legs, it will harm their hooves, it will get into the, the soft part of the hoof underneath and cause very painful cuts and abrasions. So they pretty soon learn not to walk in there. How long is it going to take for all of that to be decomposed, to be broken up, and then start into the process of succession? Will it start into this process? So it took about, I think, like 25, 30 years for the last site to be broken up. I go back and revisit Yellowstone National Park and go to some of the places just to take soil samples and see if everything's coming along just the way we expect, and it always is. Now, we didn't go out and apply anything because in national parks, and most of the parks in the U.S., you are not allowed. It's part of the mandate of the National Park Service that we observe. We don't go out and change anything. We're there just to observe and learn from these processes. So I hope that answers your question in some way. But large park areas, yeah, we do work with them, but usually money is fairly restricted.
I'd say too, if you restore the grass in the farmland area on 300,000 hectares, wild animals are going to come back regardless.
Yeah.
I'm blown away by that example.
The elephants were very happy because they went for the areas where we were putting out the proper biology. Clearly, those plants had much more flavorful or nutritious materials, and so they would choose to eat those things first.
Can I just chime in 1 sec?
Yeah.
The 60, well, no, it wasn't that big. It was a piece of what was a flooded, desertified, old GMO conventional corn and soya field, and we had to remediate these soils to make it into a permaculture kind of style market garden. And the first year, they had dug a hole somewhere to go see if they could put a well, and it filled up with water quickly, and it stunk. And I remember being there trying to put out compost and seeds for ground covers, and we couldn't be out there for 15 seconds without getting hundreds of mosquito bites, and there was nothing but mosquitoes. And the people who own that land, they had tried planting trees, which obviously died. But as the years went by, when we dropped ground covers, kept putting compost teas, and incorporating other plants into the system, that water hole became a place where frogs would come to eat the mosquitoes. And then the next year the snakes came, and all kinds of grasshoppers, and then the grasshopper population went down because the birds came in the following year, and the bees and the wasps, and now there are, herons and ducks and geese and big birds. I opened the compost pile there, and there was a snake eating a frog in my pile, and I had to go back later. So restoring the soil will have a cascade effect. We're talking about the food web. So there's the soil food web, and there's the food web, and this is the circle of life, but it actually looks more like an infinity. As below, so above. So it absolutely has a cascade effect. Just how the highest predators, like the wolves being introduced back into Yellowstone, how that had an effect, the smallest of the food chain will also have a big effect. And these are big indicator species in ecological conservation studies, so absolutely.
Excellent, thank you, Vivian. That's a good example. Like just slowly that biodiversity increasing as the land repairs itself. I've seen that sometimes, like digging a pond, and then in the Midwest, then all of a sudden you hear frogs returning, and then you're like, aha, they're back. The frogs are back when they've just heard, it's just been glyphosate fields and it's been silent. It's a pretty cool thing to hear. All right, quick question. This is from Tim. He asked this a few times. He was like, if I store finished dried compost in covered plastic bins, how long will it last? And he also said, does finished compost go bad if you store it for later use?
And Vivian, chime in whenever you want. But he said storing dried compost in plastic. When you dry anything, it's a preservative. Microorganisms can't function. They're not going to be decomposing anything if it's completely dry. I don't know any microorganism that can manage to do its thing when there's absolutely no moisture. Now, look out for humidity, because humidity will increase the moisture, and there are microorganisms that can grow when it's just been very humid. But if it's truly dry, you've put all the microorganisms in that compost to sleep, and they are going to stay asleep until things get moist again. Coming out of those dormant stages can be very difficult for some of those organisms. You're going to lose a number of species. You're certainly going to drop the population numbers of your microorganisms, but if as you wake up your compost that has been put in the plastic and stored for a while, if you put in foods, if you maybe put in an inoculum of really beneficial organisms, you could pretty rapidly get that compost back up to functioning with all of the microorganisms happily growing and doing their thing, because there's going to be quite a few foods that are now available that the organisms who used to live there didn't make it through the drying cycle. What was the second part of that question?
I believe it was, well, it was, storing dried compost, and the second part was, does finished compost go bad if you store it for later use?
If you dry it out completely, it's not going to really go bad. And as I just described, you can kind of bring it back to a condition of goodness. So you have to be very careful about the way you store it. I don't like to let my compost dry down because if there's any way for the beneficial nematodes to escape, they're going to escape. They don't like it when that compost pile starts drying, downwards, 45, 40, 35%. Most of our beneficial nematodes are going to be leaving the building. The protozoa are going to go dormant. Fungi produce spores, bacteria, spores, and things, cysts. And so, storing it, you can bring it back to a condition of goodness, but you certainly can't take compost that has been stored and allowed to go dry and put it out on a field and expect to see the same benefit as you saw when the compost was full of life and activity and organisms working.
Yeah, I believe in I think, which chapter was it in Life in the Soils, you talked about an example where the guy stored it for months and then the levels of fungi dipped, and yeah, that was a super revealing example. So as a quick, I'm going to take 30 seconds just to remind everybody. So if you look right here, I'm going to send out the link to the Life in the Soils classes along with the replay, just so everybody has that link if they want to take advantage of the offer. And you're also going to get your free 1-week membership to Sustainable Design Masterclass. So check your inbox for the replay. You'll get it from Raleigh at sustainabledesignmasterclass.com. You'll be able just to reply, and I'll send you your free pass. And for you want to take advantage of other webinars we've done, the last one was with Tom Duncan on restoring wetlands and stopping algae blooms. It was incredible, just incredible. It was like the solution to algae blooms, and you can find that on sustainabledesignmasterclass.com, and you can watch any of these on demand. And this replay is going to be free for a week, and same all of other Elaine's replays. So take advantage of your free pass. Do it. There's a lot of amazing information in this, so take advantage. I implore you.
Yeah, and the offer is good until Tuesday. Is that right, on Elaine's classes? It's
Tuesday. Basically Monday night. It's good till like Monday night at like midnight, so if you want to take advantage of it.
There you go.
All right, so when we get back to the questions. All right, so, whoop. Sorry, my thing was freezing here for a second. Man, 320 years sticking around. Elaine, you, like always, you are a champion for sticking around for 3 hours straight to answer all these.
Hey, Ral, if I can ask a question from the...
Yeah, please.
You want? Okay, there was one that Grant Goodale has been trying to get answered for a while.
Okay.
We want bacteria-dominated teas for foliar applications. Are they the main organisms that protect leaf surfaces, or should we have protozoa, nematodes, etc. also? Thanks.
We did a study with Western Sustainable Agriculture and Research Education, where we were looking at coverage of the leaf surface. And what we saw is that if we had an already existing disease on that leaf surface, we had to get it covered at least 70%. And of that 70% coverage, we had to have at least 5% of that be fungal. So it's not a lot of fungi that you have to be putting out there, but you have to have at least some fungi going and getting on the coverage. So 65% coverage, absolute minimum to control an already existing foliar disease or insect problem. 5% had to be. If you didn't have that fungal component in there, we just didn't see the protection. And we were working with grapevines. We were working with some different nut trees like filberts and some roses, things like that. So it's not, we didn't see that it was specific to a different plants. All of the plants seem to have the same sorts of requirements. So you don't have to have a strongly fungal tea when you're dealing with pests and diseases. When you want to have nutrient cycling, when you want to get a little bit of foliar food input into the plant, then you do have to have the protozoa and the nematodes if you want that kind of topping off the nutrient concentration within that plant. Nutrient cycling needs to happen on the leaf surface just like it does around the root. And so the bacteria and fungi growing on the exudates being produced on the leaf surfaces, from the stems, on the bark, so every place on the plant, in the flowers, in the surfaces of the fruit, exudates are being produced for the specific purpose of growing these bacteria and fungi, which then take up nutrients. And it's always kind of interesting to think about isn't dust always bad? No, because it does provide that not plant available form of most nutrients. And so the bacteria and fungi pull the nutrients out of the dust, out of the particulate material that land on that leaf surface, on the plant surface. Now those bacteria and fungi have all those nutrients inside of them. They have to be eaten by protozoa and nematodes in order for the soluble nutrients to be released, and that's what needs to go into the stomate. The higher the concentration of bacteria and fungi on that leaf surface, the more active they are. The higher the CO2 concentration right around the surface of that leaf, which is what causes the stomates to open. So we want to be thinking about all of that when we want to top off the nutrients. We've got to have the protozoa and the nematodes in that compost tea so we can have that aspect of benefit to the plant. When you're going strictly for the disease control, probably don't have to worry so much about the protozoa and the nematodes. On the other hand, maybe we want those bacterial feeding nematodes present, the protozoa present when it's a bacterial disease that is harming our plant. We want to see those fungal feeding nematodes when we've got a fungus attacking our plants. A lot of times when we're dealing with insects, we want to be adding a specific microorganism that will attack and consume the chitin layers, the hard shells of the insect pests. We may want something that will be able to consume the larval stages or actually go and decompose the eggs. So think about what stage you want to be controlling the insect pests, and so you're putting out a compostee that has those organisms that are going to give you that future control. Okay?
Excellent. Okay, so there's two questions I want to get to. One was another from Keith Johnson. I think his was about, come on, where'd that question go? It was about digesting plastics. Well, let me try. Oh, here we go. Fungi have been discovered that eat plastics, since microplastics have become prevalent in the ocean and can be dispersed over land by storms and hurricanes. Can we anticipate that this material will be consumed by indigenous fungal species?
And yes, you have to provide the right habitat, however. So usually decomposition of plastic by either bacteria or fungi requires an alternate organic material for that bacterium or fungus to gain energy. They've got to be decomposing food in order that they'll make the enzymes to tear apart the plastic. So there are certain parts of the plastic that they can go after and obtain energy from, but it costs energy to make those enzymes. The ultimate return will be positive, but making those enzymes to begin with, very energetically, very expensive. And so, yes, we certainly can decompose plastic. I would probably encourage for a more complete, go read the Radical Mycology book, Peter McCoy's. Probably got a lot more specific information than I can give you right now.
Yeah, Peter is awesome. That book is just the thick, dense Bible of fungi. It's amazing.
All the things fungi can do.
Yeah.
A little bit, in my opinion, a little bit lacking on getting really clear about the specific conditions that those fungi need to be in order to perform that function. So, and we don't know everything yet either, so let's not criticize anybody for not knowing everything there is to know about everything.
Yeah, fair enough. Okay, there's a question from John that I remember I met one of your students at Soil Not Oil who started this incredible, she said it was a scalable movement to create fungal dominant compost that anyone can use. I just want to bring up that example real quick. But okay, John said, John Valenzuela, he's a exotic fruit expert in California, he's a cool guy. He says, could Dr. Ingham please discuss the use of aromatic Mediterranean herbaceous plants as orchard intercrop for uses as a source of in situ pruned mulch for forming more tree beneficial fungally dominant soils? Ooh, long sentence. He said, I heard this from Michael Phelps, and she met you in 2001 at a health conference in Maui. Cool.
Yeah. We always have this attitude in orchards that we have to have bare soil underneath the trees, that we'll have diseases and pests growing in any organic matter, or if you allow any weeds to grow underneath the trees, that it's all going to be bad stuff. So we have to have absolutely bare soil, which is insanity. That's just crazy. You're asking for all in that soil. And most of the time it's dirt because we used herbicides to get rid of all of the weeds and other plants that might be growing under there. We're constantly putting on pesticides. The preventative sprays drive me absolutely nuts, because why would you go out and put on a toxic chemical before you even have the problem? Because why spray something if you don't need to spray it? Well, we want to make certain it never rears its ugly head. Well, let's use the proper biology in that soil. And so if we can get understory plants growing around all of the trees, something that's complementary to that fruit tree, to that nut tree, or to that whatever kind of tree you want to grow, something that shares the same mycorrhizal fungi. So there's always a reservoir of activity going on. There's always food being pumped into your overstory tree. They share, the understory trees and the other plants sharing mycorrhizal fungi. They're all healthy or they're all sick. And so let's make sure that all of that biology is being sustained. Let's have the help from those understory plants to make certain that no disease causers, no competitors, no problem organisms can move into that soil, can get to your tree. Everything walking through this really beneficial set of microorganisms around the tree and then crawls up the tree, it's going to inoculate all parts of your desired crop tree. So absolutely, we want to be putting in the foods to maintain all of this biology and keeping it active, maintaining the diversity of activity that we want. You know, that tree may not need this one species of bacterium any time except for maybe 2 weeks every 10 years. But when those conditions happen, it's absolutely necessary that that particular bacterium or that species of fungus or protozoa or nematode is critically important that it be present. How is it going to be maintained? In a place where there's nothing else but the exudates from that tree moving into that soil, trying to sustain everything. It's not going to happen. We need to have those understory plants, and we need a diversity of understory plants to maintain that biology, so the critically important things that are rarely required are there and will be able to perform their function for that short period of time that they need to be there. When we look at understory plants, when we're getting those later successional species where we're matching up fungal to bacterial biomass ratio of the crop with the understory plant, another thing that we see is we don't have weeds because we've shifted that fungal to bacterial biomass ratio to something where no self-respecting weed can grow. We might have a few grasses, highly productive grasses come up. We might have, you know, some of the later successional herbaceous things try to come in, but it's pretty easy to just walk by and pull them out as you're inspecting your orchard for various things. Water retention. We retain so much more water. Every herbicide salesman always goes back to those series of papers written back in the 1930s and the 1940s where they show that if you have any plant growth underneath your crop plant or underneath your trees, anything else growing in the system is going to remove water, and now you've got competition for water, competition for nutrients by these weedy plants, so you have to kill them all, you have to use herbicide. Well, what kind of plants were they always, in those systems, they were always dealing with weeds. But what if we have something other than weeds growing? Now, will there be these weeds that are notoriously bad at blowing off all the water they possibly can? You know, they don't care about how much water they use because they only have a 2-week life before they're going to go dormant and produce seeds, billions of seeds, and the seeds disperse, and they have such short life cycles. They don't care about the fact that they're not leaving water for anybody else. They don't care that they're sucking up all the nutrients here in the top layer of the soil where we have forced all of our crop plant roots to be because we've allowed compaction at the plow depth. We've imposed that compaction on the system. So what happens then when we're growing something that's at the same stage of succession as our crop plant? Now instead of this plant blowing all the water off, because what does it care? It cares a lot because it's a perennial plant too. So it's not wasteful of water. It helps hold and retain. As soon as we get all of that soil surface covered with that understory plant, we reduce evaporation. Evaporation off the surface of a green plant is going to be much, much less than evaporation off a brown surface of the soil. So we're going to hold more water. There are several papers from Washington State University where they actually document this. Put weeds in, oh yeah, you would never want to have a weed in your soil because it's going to blow off water, it's going to suck up all your nutrients. Yes, they're problem plants, but move on in succession. And the presence of those plants decreased evaporation. It held more water. The water went deeper because those soils around the root system of those plants was building structure. Microaggregates, macroaggregates, larger pore spacers were being produced. Infiltration of any dew was immediate. So all these cover plants, we want to start developing and understanding which are the good ones. Right now in our work up at the farm in California, here in California, we're finding that dichondra is a very good cover plant. It has all the characteristics that we want. You seed it in, the seed's not very expensive. The plants come up, they don't typically grow taller than about that. They spread, so they'll very rapidly cover that whole surface. They're crowded close enough that there's practically no weed seed that can get in there. If it does start growing, the dichondra has a fungal to bacterial biomass ratio of around 0.8. So good for most of our general vegetables. Maybe not the cover plant you want in your pasture, but Gabe Brown has a whole list of really good cover plants, short, low-growing to intermediate size, that keeps all of that soil covered with plant material all year long. So do we know everything about this yet? No. We're still searching for what are the plants that fit the characteristics of the permanent perennial cover plants that get rid of weeds because of that shift of the fungal to bacterial biomass ratio, that will build structure and hold the nutrients in the soil, build structure and hold water in your soil, as well as maintaining all of your life below ground. Okay?
Oh boy.
Oh, get Elaine started on this topic.
That's not an answer. I don't know what is. Okay, here we go. Let's see. Laura Lee Holman has been waiting a little bit. She says, I just was asking about deep mulching techniques in gardening. We use deep hay in the veggie garden around trees, roost out methods. Would Elaine recommend that? Certainly we've seen dramatic improvements on her soil.
Yeah, absolutely. Because you're putting in a whole lot of these foods for more fungi than you are bacteria typically, especially with the kinds of things that Ruth was suggesting, much more of that woody component and great fungal food. I would typically till all of that in before I planted any of the perennials, because once that perennial gets going, you don't want to be disturbing the root. Well, that's kind of obvious. So yeah, I just think about what it is you're really doing, and I think that's what I've been doing with my career, is answering the questions about, well, so why does that work? Why does that work over here, but it doesn't work over there? And so when you start understanding the high in cellulose, high in lignin, high in complex compounds, those are all fungal foods. There are very few bacterial species that can use those complex cellulose, lignins, chitins, things like that. Fungi, those are fungal foods. Bacterial foods are the simple sugars. You get into a kind of an area of fighting between bacteria and fungi when it's a mixture of some of the more complex sugars and some of the simple sugars. There's going to be some conflict there. Who's going to win? Depends on other environmental conditions, other sources of foods that might be present. So what stage of succession is your plant? So if you're trying to grow brassicas, They need bacterial dominance. They want actinobacteria around their root systems because those actinobacteria select, well, many of those species, not all, but many of the actinobacterial species, especially around the root systems of Brassica, will physically with exudates being produced by the actinobacteria suppress mycorrhizal colonization. We don't want mycorrhizal colonization in the brassica. The cole, the kale, mustards, brassica crops doesn't benefit them to become mycorrhizal. When they become mycorrhizal, it means that mycorrhizal fungus is probably being directed by some other mycorrhizal plant to force mycorrhizal colonization onto the brassica root system, and then the mycorrhizal fungus pulls nutrients out of the brassica and brings it back and feeds the mycorrhizal plant. So those actinobacteria can be really important. So as we're putting in foods, what are we putting in foods for? What is the kind of organic matter that you're adding and mixing deep into the soil? So when we often start working in something it's not soil that we're dealing with, this is dirt. And it's got compaction layers that are just frightening. We go in and till. For the last time ever that you'll have to till, we'll go in and till that compost in to get that whole depth of the soil down, 4 feet, colonized with the right sets of microorganisms. Then when you plant your plant, here are the exudates to maintain the biology that's already down there, already starting to build structure to combat with the diseases, open up all of that compaction and get oxygen and water, and hopefully now soon roots growing through it.
All right, excellent. I think one thing we can do, just for convenience later, I'm going to officially stop the recording and we can keep going. But just for space, so I don't have like a 4-hour, huge webinar to send out, I'm going to officially stop the recording. Thanks everyone for tuning in, who's listening into the replay of the Sustainable Design Masterclass. It's been an amazing session with Elaine Ingham. We're going to stop the recording, but you can tune in to more webinars later.
And I do need to get going, so okay. I probably need to maybe answer 1 or 2 more questions, and then that's it.
All right, fair enough. Oh, I guess it just won't let me stop the recording. Whatever. Okay, 2 more questions. This is tough. There are a lot of good ones out there. Oh, boy.
I know. Take the classes. Most of your questions will be answered in there.
I know. Super excellent. Like, every lesson is just mind-blowing. It's more interesting than anything I've learned since college. It's great. Okay, last question. Let's get to it. How about from Ute Bonsai? He's a big fan of yours. He's asking, how has the discovery of glomalin in 1996 affected your study of the soil food web?
That kind of makes me giggle. The discovery of glomalin. I have a little bit of trouble with that because we've known about glues produced by bacteria and fungi for decades before that paper was published. So they discovered glomalin. And I think if I remember correctly, in that paper it says mycorrhizal fungi are the only things in soil that produce glues, and that one just blew me away. There's a whole book on the ultrastructure of the rhizosphere. I'm not going to remember the author, but he's out of Australia. Fantastic book showing all these massive glue layers around bacteria. That in fact, bacteria make way more glue than any fungus makes. Yes, mycorrhizal fungi make some glues, but certainly not in the quantity, and therefore mycorrhizal fungi are not the only things that make glues. They are not the only things that build structure within the soil. That's absolutely crazy. So let's recognize that bacteria are the things that make most of the sticky, slimy, gluey stuff in soil. And there are literally hundreds of thousands, if not millions, of different kinds of glues that are produced just by these massive number of bacterial species. Fungi produce other kinds of glues, not just this structure, this particular glue structure that they were talking about in that paper. How many species of fungi are, and probably each species of fungus makes its own particular kind of glue. So they are holding things, gluing things onto the hyphae. They're gluing soil particles together. But really, what makes the most glue are the bacteria. Bacteria make microaggregates, and they glue things together. They glue themselves onto the surface of the root, surface of sand, silt, clays, rocks, pebbles, organic matter, and they build microaggregates. Fungi come along and they bind those microaggregates together, kind of like putting string around a set of envelopes or something. They hold things together. Bacteria make the smallest. Fungi make the intermediate size, macroaggregates. So discovery of glomalin. We've known about glues in soils for a long, long time. Go back to textbooks that when I took introductory microbiology back in college in 1960, whatever it was, they talked about the glues that these microorganisms make. They didn't call them glomalin, but it's clear that we knew and understood as far back as that. So that paper went a little overboard in discovery.
All right, fair enough. All right, Elaine, well, thank you again so much. That was a powerhouse. I can sure everyone got a ton out of it. I'm getting floods of emails saying thank you, thank you, thank you. That was amazing. And so I so much appreciate your time. And for the folks who don't know about Klebsiella planticola, thank you for saving the world again. We can't thank you enough.
Klebsiella planticola.
Okay,
and of course,
I said that wrong.
When you're working with Klebsiella planticola all the time, we started calling it Kleptomania planticoli.
Yeah.
Yep, you got to goof off. You have to have fun in the lab. And I want to thank you very much for hosting this and doing all of the detail behind the scene kind of work. This would never happen without you.
You're very welcome. Anytime. This is great. People want to learn about soil. Like this is one of the only things we do where almost 700 people show up and they stick around for 3 hours to learn about soil. That's phenomenal, and I want to keep doing this as long as people show up, which is great.
Thanks.
Thank you, Vivian.
Thanks, Elaine. Thanks, Riley.
Thank you, Vivian. Yes, it's always great to have you here. Thank you so much for what you're doing up in Canada.
Yeah, and I look forward to seeing you up in Montreal at the Living Soil Symposium.
Yep, that is going
to that.
Very fun. Yep. You got all of the whole crowd in one place for, what is it, 3 days?
Yeah. We're going to make it count.
Yep. Okie doke. Thank you all very much.
Take care.
Yep. Got to go deal with the farm.
All right, everybody. Thank you so much for still sticking around with us. Those of you who are still here. So Alicia says, hello, Mark, and biodiversity is the key for all ecosystems. Agreed. Yep, definitely. Okay, so this is it for tonight. Come back next week, and also on Thursday, we're going to have Talk with Brain, and Friday, Elaine. So have a great rest.